Hello, I'm Jake Seboly, and this is my Project 2 PowerPoint on methods of heat transfer. So what is heat transfer? Well, it's a process involving the exchange of internal energy between two substances. As you might remember, temperature is the absolute measure of the internal energy of a substance, and heat is involving transferred internal energy between substances. So when you're transferring heat, it just means that you're transferring internal energy between those substances. Two substances are in thermal contact if there is heat being transferred between them at the time, and they are in thermal equilibrium if they're at the same temperature, meaning that no heat is being transferred. There are three major methods of heat transfer, and those are conduction, convection, and radiation. And in this presentation, I'm going to define each one, give some examples, and maybe some formulas that are related to each type of heat transfer. So, first, let's define conduction. Conduction is the transfer of heat between touching molecules within an object. And it happens because molecules are in their places and they're vibrating, and so molecules that are adjacent to each other are often going to collide. And in these collisions, they transfer heat energy from the more energetic molecules to the less energetic. So by that method, heat is conducted throughout a substance. Typically, if a hot object touches a cold object, it will conduct heat to the cold object until they're in thermal equilibrium, or typically at the same temperature. Now, different substances conduct heat with different effectiveness. In general, metals are the best conductors, and they do a better job of it than nonmetals and fluids. There's a formula that can tell you the amount of heat conducted by an object, and that's heat conducted over a certain amount of time is related to the conductivity constant of the object, the surface area, difference in temperature, and the distance between the two objects. There are a lot of real-life examples of conduction to consider. One that you might think of is an ice cube melting when it's held in a person's warm hand, or a glass of ice water becomes cold on the outside, and you can tell that because of the condensation drops that form on it. If you put a pot of soup on a stove burner, the flame from the burner conducts heat into the pot and warms the soup. If you use a metal wire to roast marshmallows over a fire, you'll notice that the metal wire becomes hot, and that's because heat is conducted throughout the metal. Objects that are poor conductors are also serve practical uses. Insulation in a home is a purposefully poor conductor, and that prevents loss of heat through the walls of the home. And when we're talking about thermoses, they have vacuum space in the walls of the thermos, and that prevents loss of heat from the liquid to the surroundings, or vice versa. Let's go ahead and do a math example here to figure out how much heat is lost through the walls of a home through insulation. Let's assume we've got a wall with an area of 15 meters squared, layer of insulation 10 centimeters thick, and it has a K value of 0.042, meaning it's a poor conductor. And it's a cold day. The temperature outside the house is freezing, and the temperature inside is 20 degrees Celsius. And you can see the formula there and the solving it, and you'll get 126 joules per second leaving the house. Now that seems like a large amount of heat, but there is a lot of air in the room, and air has a high specific heat. So just that much is not going to be enough to significantly change the temperature over short periods of time. So what about convection? Convection is a type of heat transfer that occurs within fluids, and it occurs when hot liquid or gas moves to take the place of cold liquid or gas, carrying heat with it. And it is much more effective than conduction in the cases of liquids or gases because liquids or gases tend to be poor conductors. So convection becomes an important method of heat transfer for them. Now you know that hot liquids or gases are typically less dense than cold fluids. So natural convection occurs when a hot fluid rises and cold fluid sinks. And that's one way to spread heat throughout a substance. Another method is forced conduction, which typically involves a machine such as a fan or a pump, and that forces the fluids to move. Those are useful in cases such as refrigerators or air conditioning or heating that cause temperature differences that wouldn't naturally occur. So here are some examples of convection. You might be heating a pot of water on a stovetop burner and you'll see the bubbles coming up. That is partially involved with hot water at the bottom that's heated first rising to the top to replace cold water, and so that carries heat to the top. As far as weather goes, you'll see warm air at the Earth's surface rises and it condenses to form clouds. Cold fronts and warm fronts involve temperature changes that occur due to moving air. You'll feel the wind bring in cold air or warm air. Land and sea breezes result from diurnal temperature differences over land and water, and so convection starts to bring that difference into equilibrium and produces that wind. And as I said earlier, forced convection is used in machines such as refrigerators to ensure that the inside stays cool. So the final method of heat transfer is radiation, and that refers to heat that is transferred via electromagnetic waves. The special thing about radiation is that it does not require a medium. This transfer of heat can occur in a vacuum, and when we get to the examples, we will see why that's important. Now, infrared waves are the part of the EM spectrum that is most effective at transferring heat, and these waves are invisible, longer wavelengths than visible light, but you can feel them as heat. Now, all objects have an emissivity value between 0 and 1. 1 indicates a perfectly black object that effectively radiates heat, and 0 indicates a white object that does not radiate heat. And that becomes important when we consider Stefan's law, which finds the energy radiated by an object per second, and it's got a formula there. And so that depends on the surface area of the object, the emissivity, the temperature, and the Stefan-Boltzmann constant. And you'll see that the temperature is raised to the 4th power, so the radiative power of an object is strongly dependent on its temperature. Here's some examples of radiation. An important one is that the sun heats the earth through radiation during the day, causing the temperature to warm. Then at night, on the dark side of the earth radiates heat into space, and that's why the temperature cools down at night. Another case of radiation is microwave ovens use it to heat food. Heat lamps in cafeterias use radiation to keep food warm. And it's also important to note that the human body radiates heat, and that explains why crowded rooms with a lot of people in them typically become warm or even hot, because there's so many bodies in there radiating heat. So let's solve a problem related to how much energy does the sun radiate per second. Now, if you look it up, you'll find that the sun has a surface temperature of 5,800 kelvins, surface area of a lot of square meters, 6.16 times 10 to the 18th, and we'll assume an emissivity of 1. So, plugging those into Stefan's law, we get a radiative power of 3.95 times 10 to the 26th power watts, or joules per second. So, of course, that is an incredible amount of power, and that's why the sun can strongly heat the earth, even though there's a distance of 93 million miles between us. Let's do another example related to how much heat does the human body radiate. Now, an average adult human has a temperature of 310 kelvins, a surface area of 1.9 square meters, and an emissivity of 0.7. So if we plug those numbers into Stefan's law, we get an answer of 696 watts, which is a lot of heat. This is close to the amount of heat produced by a 100-watt light bulb. So that explains why a crowded room becomes warm, because just imagine a bunch of 100-watt light bulbs in the room. That would really heat it up. So, in summary, there are three major types of heat transfer. Conduction is heat that is transferred by touching molecules within a substance or between two adjacent objects. Convection is heat that is transferred through the motion of liquids or gases. And radiation is heat that is transferred by electromagnetic waves. And here are the references. Thank you for watching.